Hey guys, we're Northern Oklahoma College, College Algebra. This is Math 1513. I'm on Chapter 2, Section 4, and we're going to write a quadratic function in standard form by completing the square. Alright, now before we get started, I want to show you a few things about quadratic functions and what they look like on the graph. I'm on the coolmath.com graphing calculator website. You can see it up there in the URL there, coolmath.com. You can just Google it. Google CoolMath free online graphing calculator, or just CoolMath graphing calculator. Okay, the first thing I want to show you is a simple x squared graph. So I'm going to type in x and I'm going to raise it to the second power. So that's x squared. And all I do is hit my enter key on my keyboard, and I hit enter and it comes up and it graphs it real nicely there. So that's what a simple x squared graph looks like. It's a parabola. It opens upward. If you see where I'm hovering right here, that's called the vertex. All right, in this case, our vertex or turning point is a minimum. It's a low point. All right, that's the very lowest point on the parabola. So we call that vertex a minimum. Now what happens, I'm going to go back up here and I'm going to put a negative sign in front of my x squared. What happens when I do that? Well, the negative, remember negative means opposite? The negative flips it, so it's pointing the opposite direction. So now my parabola opens downward. Here's my vertex. My vertex is still in the same place, but now my vertex is a maximum. So remember this, take a little note. If there's a negative in front of the x squared, you're going to have an upside down parabola. It's going to open downwards. If you have just a regular x squared graph, it's going to open upwards. Okay, now watch what happens when I do a couple things to the x squared graph. There's my regular x squared graph. I'm just going to add 1 to it. And look what happened. It shifted the whole graph up 1 unit. What if I add 2? It shifts the whole graph up 2. What if I add 5? It shifts the whole graph up 5 units. So this number out here on the end, after the x squared, tells you how far the graph shifts up or down. Now I didn't show you it shifting down, so let's just change it to minus a number. I'm just going to pick -3. And see how it shifted my x squared graph. My x squared graph was at the origin right here, but now my minimum, my vertex, has shifted 3 units down. Same thing if I minus any number. If I minus 4, my vertex has shifted 4 units down, and so on. So the x squared, you learn a lot of information here from watching this. The x squared tells you that it opens upward. The -4 on the end tells you that it shifted down 4 units, or 3 or 5, or whatever that number happens to be. So the number on the end tells you which way it shifted up or down. Alright, the same thing happens on my negative x squared graph. Now the negative flips it upside down, so my vertex is at the origin, and now it's a maximum because it's the highest point on the parabola. And whatever I add or subtract out here on the end is going to raise it or lower it. So let's say I add 2. That's going to raise my vertex up 2 units. It was at the origin, it raised up 2 units. Or let's say I subtract 5. That's going to drop the vertex 5 units. It was at the origin, it dropped 5 units down here to the bottom. Alright, so adding or subtracting that number on the end raises or lowers the parabola. Alright, the next thing I want to talk about is what happens if I add or subtract a number before I square it. So for example, I'm going to put this x in parentheses, and inside the parentheses I'm going to subtract, let's say, 3. Alright, so what's happened? Here's my regular x squared parabola, vertex at the origin, it's a minimum. What happens if I subtract 3 inside the parentheses, if I subtract 3 before I square it? Well, look what happened. The vertex shifted 3 units to the right. Now this is kind of contrary to what you would naturally think. You would think that if you subtract 3 it would shift to the left, but actually it works the opposite way. So subtracting 3 before you square it actually moves the vertex 3 units to the right. So let's try a couple others here. Let's subtract 5. That moves it 5 units to the right. Alright, what if we add? Let's add, I'm just going to add 2. Alright, so we should know by now that's going to shift the vertex 2 units to the left, and there it is. Our vertex was at the origin, and adding 2 before you square it shifts the parabola 2 units to the left, shifts the vertex 2 units to the left. And you can play with this all day and see what happens. Remember, we're on coolmath.com. So you can sit here and play with these graphs all day long and see what happens. Now the same thing would happen if I snuck a negative sign in there. That negative flips the graph upside down. So the negative tells you that I flipped the graph upside down. The parabola is opening downwards now. And adding 5 before I square it moves my parabola 5 units to the left. Okay? Now let's get real fancy. What if, now I'm going to change a number out there on the end. I don't have anything on the end right now, but I'm going to add, let's say, a 3. What happens? Okay, look what happens. A whole bunch of things happened. The negative says that I flipped my parentheses upside down, so it's opening downwards. The 5, before I squared it, says it shifted 5 units to the left. So 1, 2, 3, 4, 5 units to the left. And adding 3 on the end raises it 3 units up. So see, look at all the information in this simple little quadratic equation. That tells you it flipped. That tells you it moved 5 to the left. That tells you it moved 3 units up. All right? All right, here's a pop quiz for you. You might want to pause the video and see if you can figure it out. Tell me what this graph is going to do that I've entered in. Here's our regular x squared parabola, and here's what I've done to it. I've messed it up. Tell me what I did to it. So I subtracted 3 inside the parentheses. I subtracted 3 before I squared it. What's that going to do? And then I subtracted 6 out on the end. What's that going to do? So think about it. You might pause the video here. I'm going to go ahead and hit equals, or enter, I mean. And there's my graph. So what happened? The minus 3 before I square it tells me I moved it 3 to the right. So 1, 2, 3 to the right. And the minus 6 on the end tells me I shifted 6 units down. So 1, 2, 3, 4, 5, 6 units down. So look where my vertex moved. It was at the origin. It shifted 3 to the right and 6 units down. All right? What if, it's pop quiz time, what if I squeeze a negative in front of the parentheses there? What's going to happen now? And it flips it upside down. So the same thing happens to the vertex. The vertex still goes 3 units to the right and 6 units down. But putting the negative in front of the whole mess flips the parabola so it opens the other way. So now I have a maximum instead of a minimum. All right, so we've learned a whole bunch of information here. We know that the very bottom of my parabola is called a vertex. Okay, and it's going to have coordinates. This vertex has the coordinates 3, 2. When it's the bottom of a parabola, when the parabola opens upward, we call it a minimum because it's the lowest point on the parabola. If the parabola is flipped upside down, we would then call it a maximum, but your vertex would still be at the same place. So if I flip it upside down, now my vertex is called a maximum, but my vertex is still 3, 2. Okay, one thing I wasn't able to show you on the Cool Math site was this little imaginary line that goes down the center of the parabola. That's called the Axis of Symmetry. I got to see if it's 2 M's or not. Yes, I had to look it up. It's 2 M's. Symmetry. Okay, that's called the Axis of Symmetry. That's an imaginary line that goes right through the middle of the parabola. You can think about it splitting the parabola exactly in half into 2 mirror images. All right, now that we know what these functions look like on the graph, we can talk about how to calculate that vertex and that line of symmetry and actually draw the graph. All right, this is what the standard form of a quadratic looks like. Now, we talked about a bunch of this already. This number in front is going to tell you whether the graph opens up or opens down. Okay? Opens up if positive, okay? Oops, positive, and down if negative. Now in my examples, I didn't put a number there. I just put a positive sign or a negative sign just to show you the graph was opening up or down. But if they do put a number in front of the parentheses, it just tells you how skinny or how fat the parabola is going to open up. And you guys can play around on coolmath.com and put some numbers in front of the parentheses and see what it does to your graph. See how it skinnies up the parabola or widens the parabola. All right, and some other information we can pull from this equation when it's in this form is that the h, the number here, and the k will tell you where your vertex is, where that minimum or maximum point is. So if you pull the h and k out of the formula, you know where your vertex is. And finally, this h, if you put it right here, and write the equation x equals h, that will give you the equation of that line that cuts through the middle of the parabola that we call the axis of symmetry. Okay, what if I have a nice easy one like this? Now this is my standard form of a quadratic function, and I have given you this right here, and I want you to tell me a couple things. Okay, so given this equation, I want you to tell me, does it open up or down? What's the vertex? And what's my axis of symmetry? So, does it open up or down? You look at that number in front of the parentheses being squared. That's my A. A is positive. It's a positive 2. Positive means it's opening up. The 2 just tells you how skinny or how wide it opens up. The vertex, my vertex is going to be my H and K. It's going to be the number being subtracted and the number being added, if you want to think of it that way. So my vertex is going to be 3, 1. And finally, my axis of symmetry is going to be x equals h. What was my h again? My h was 3. So that tells us a whole lot of information. Let's graph what we know so far. Okay, I know my vertex is 3, 1. I know it's right there. 3 steps to the right, 1 step up. I know my axis of symmetry is x equals 3. That's that dashed line. And I know that since it's a positive a, I know it opens up. Okay? Now what we need to do now is plot a few more points. We need to plot at least 2 points on the left and 2 points on the right of the vertex. So I'm going to have to use this x of 2 and that x of 1 and this x of 4 and that x of 5. I'm going to have to run those x's through the equation and figure out where my other 4 points are. So I'll make a little table here for you. Okay, so I'm starting a little table here, and I know that 3, 1, I know that's my vertex. I already have that point. Now to graph this, I just need a couple points on the left and a couple points on the right of the vertex. So I'm going to pick 1 and 2 on the left and 4 and 5 on the right. I'm going to run them through the equation and see what y matches up to that x. So I'm on number 1 here. I'm putting 1 through the function. I'm going to see what y pops out. So I took out the x, put in the 1, and now I do all the math, and I get 9. When I put in a 1, I get out a 9. Now I'll do the math for the x equals 2. So take out the x, put in the 2, and do the math. And so when I take out the x and put in an x of 2, I do the math and get 3. So 2, 3 is one of my points. Now in the same manner, I plug in 4 and 5. I'll let you guys do the math. And you'll see that I get the same y's. That's what a parabola does. It goes down to a low point and then goes back up using the same y's. So let's graph those points now. Okay, I've graphed my points. Now you see I'm going to have to make my parabola a little skinnier than I thought it would be. That's what that 2 does in our equation. This 2 over here, that makes the parabola a little skinnier than I thought. All right, so we found our vertex right there, and then we found 2 points on the right and 2 points on the left. We just had to run these x's through our table to find the points and graph it.